Other one, it's February 13th. I'm dog tired. Second day in a row. I didn't finish until 3 minutes ago. Dude, this is not sustainable. Man. Tired. Every day. All I can think about is tired and tired and tired. Alright, at least I can do this to cheer me up. But my cat is sick, so not much to cheer. We set up an appointment, so tomorrow evening we'll go have the cat check up. So yeah, it's just things. It's just things. Product of the last k numbers. Design an algorithm that accepts a stream of integers and retrieve the product of the last k integers on the stream. When implemented, this initialize the thing. Oh, I forgot again. We have to public and then we can assign it inside, right? Oh my goodness. Constructor. Yes. Alright, you can use default constructor. Oh, no, you can use the parameter, this one, right? This one, okay. Add append an integer to the stream. Get product returns the product of the last k numbers. Always a kernel has at least k. The product of any contiguous sequence of numbers will fit into a single 32-bit integer without overflowing. Thank you very much. So we add 3, 0, 2, and then get product. So 3, 0, get product of 2 is 20, and 3 is 40. What else? Some suffix or prefix, I don't know, prefix product. Yeah, I think it's prefix product divided by prefix product, and that's it. Or is that suffix I don't know. Man, it's tough. Yeah, so each time you add one, you just produce a new product, you save it, right? And then you produce a new product, you save it, and then it's just gonna be the total divided by this, and then it shall be okay. So that's not too bad. It's not too bad at all. Man, sometimes I just like, why? That could be some misconception from my side, because I always think, you start working, it's gonna be easy. Your job is gonna be easy, but it's not easy. I think public. We need a like seriously, I thought things will be easy. It was not easy at all. Alright, so basically we need to do is, I wonder if I need a get initial one. What was the question? The last k. So I need the total minus the last k, right? So if a total is 5, I get last 2, so it'll be 3. So 0, 1, 2, 0, 1, 2, 3 is not going to work. Right? But if I start with position, if I have a dummy, okay? If I have a dummy, and then 1, 2, 3, 4, and 5, right? And now I say I always get the last one divided by, if I want the last 3, so 5 minus 3 equals to 2, so I just get 2. That would be last 3. Five minus 3 is equal to 2. Yep, I think that's the right way to go. So basically what we do is pprod dot pushback 1, and then every time when you add, we should say pprod dot pushback pprod dot top back times num. Get product will be return pprod dot back divided by pprod dot size minus k. Alright, this is not expected that everything can be done in one line. Good point. I guess you're not that smart. Ugh. 0. How do you handle with 0? Ah, Lord. The difficulty is with 0. If we don't have 0, things will be much easier. Okay. Gosh. Yeah, the total will always be 0. That's actually a good question. How do we handle 0? So start with 1 and then 3. And then we have a 0, but maybe we don't do 0. Maybe this is 0, which means anything that included in this will be 0. So I probably need to indicate where the position is for 0. So now I saw, the position of 0. How do we know if a stretch will include 0? Good question. How do we know? We can binary search. We can know if. Oh, it doesn't matter. That doesn't matter. I just need the because I just like if I reach him back, I just need to know if there's any 0. So I just get the largest, right? I need the largest index of 0. So when I reach back, if it doesn't hit it, then we won't be 0. But if it hit it, it's always going to be 0. Okay, so that's how you handle 0. And if that's how you handle 0, then can we say every time we hit 0, we just reset to 1. So now it's going to be 2, now it's going to be 10, now it's going to be 40, right? So if I will get a k, right? If I get a k and k is equal to 4, right? 1, 2, 3, 4. So k equal to 4. So the total length, right? Total length with the vector is 1, 2, 3, 4, 5, 6. Now we have yeah, it's fine, 6. So if I say 6 minus 4 equal to 2, right? 0, 1, 2. So its position is 2, right? That's supposed to be a 0. So basically, I can use that to find the leftmost position, and then the 0 is actually 0, 1, but actually I record it as 2. The largest is 2. So now I say the position that we reach back is smaller or equal to this, so this will be 0. And then if I hit another 0, I just reset to 1, because you cannot multiply over that, right? Okay, so some small change. So we also need a int max 0 index. Okay, so now we just say max 0 index is equal to 0. All right, and then add num. So we're gonna push back that depends, right? Depends. We say if num is equal to 0. So if num is 0, then we say, ooh, you need a tick. God Lord, int index is also equal to 0. Actually that's not true. Indexes start with 1. Every time we add index, we'll jump forward. So if it's equal to 0, then we say max 0 index equal to index, and pprod dot push back 1, else pprod dot push back this, and then we do index plus plus, right? We move index forward. So here, if pprod, I'm going to say n equal to pprod dot size, right? I'm going to say if n minus k is smaller or equal to max 0 index, return 0. Otherwise, we return this. However, pay attention to the complication of zeros. if the if the suffix covers a 0, then the product will always be 0. Thus, we need to keep track of the largest index, that is 0. Also, whenever we hit the 0, we assign the value 1 to the prefix product array. All right, this, let's see, it's a much more, now this feels like an intermediate problem. Earlier was a little bit too easy. Okay, we're now right. 423. I think we're missing stuff. 4. Huh. Did you anyway, when we hit here is 1, 2, 3, 4, 5, 6. Right, it shall be 6. So n is 6 and k is 2. 6 minus 2 is 4. 0, 1, 2, 3, 4. Really? Huh. Well, I am surprised. 0, 1, 2, 3, 4. I need a -1. Huh, okay. Well, -1 it is. I thought we don't have the -1. Yeah, I guess you have to. Yeah, it's, once you figure out, it's not that hard, but it's an interesting question. It's not that straightforward. I mean, it took us almost 20 minutes to finish it, so really not that straightforward. It's just the handling of, let's see, how do they handle? Size, pushback, yes. Size is 0, size to 0. Oh, you don't even have to keep track. You just reset it. Oh my god. That is absolutely correct. And if it's just larger than size. Ugh. Alright, I agree. This is actually better. Because you reset. Oh my good. My goodness. Yeah, that's right. You just reset it. I think reset probably is faster because you don't have to keep building up. Every time you hit a 0, you just reset. Every time you hit a 0, you just reset. You know what? I like the reset idea. I want to code the reset. It's the same, but you know, I think it's much better in terms of memory usage. This is from the official solution, which resets the array, the prefix product array, each time 0 is encountered. Alright, so if you reset if you reset, how do you know the 0? Well, I mean, you have your current. So yeah, why do we need a size? What does the size do? K larger than size. Ah, screw you. We don't need that. We just reset it. Right? We just reset. Okay, so we got this. Oh, we don't even need any of this. I just do this. Wait, something is wrong? To public. I don't know. Expected number name. After declaration. Wait, what? I don't understand. What problem did I have? I hate it. This is yeah. What the hell? What did I do wrong? I copy and paste the entire stuff. How could this be wrong? What in the world? Okay, this is a different problem. This is. Oh, I know why. Dude, I know why. I know. Oh, hold on. I know why. I know why. Here is why. Okay, so basically each time it's 0, I just reset. So we say if it's 0, then pprod.clear, and we push 1. Otherwise, we do this. Okay, and then we got its size, right? So if it's 3, if you got 3, let's go before. So if it's smaller than 0, then we return 0, which means you really can't. But hold a second. Because its size is 1 more. So, like if I have 3, but actually the size is 4, and 4 minus 3 is 5, 4 minus 4. Right, so it's smaller equal to 0. Then return 0. Otherwise, we'll do this divided by so if I have, I don't know, I have 3, and then I want the last 2. 3 minus 2 is 1. 0, 1. It looks like I don't need to minus 1. Right? Because I have this, and then I got 3, and I want 3. And total is 4. 4 minus 3 is 1. Now I do have to minus 1. Okay. Let's give this a shot. Let's see if it works. Yep. pretty good. I just think this might be faster. It is faster. I just think, because as you keep pushing, right? If I remember right, C++ will dynamically reallocate memory, which means if this array gets too big, then it takes overhead to add new memory, to allocate new memory. Now in our case, whenever we hit a 0, we'll clear it, which means the chance of reallocation is lower in this one. And we don't need the other two, and the logic is overall simpler. Yeah, that's why it's a win. 12 milliseconds, 91.95. 91.95%. That's pretty good. Okay, that will be it for today. I will see you guys tomorrow. Hopefully tomorrow will be a much less tiring day. Adios.